Hello guys, today I will try to do a explanation for my Minesweeper game. So right here in front of you you see a stripped down version of the game. This is within the world download. You can teleport here or just fly to it because it's not really that far away. And yeah, right here you can see that it's fairly small, so we will start off with that. It's only 26 deep, and every cell is 8 by 8, and then we have some stuff on the side here, as you can see, and then there's a little bit on the bottom as well, as you can see right there. So yeah, I really went for size with this build. For that reason it's really slow to reset and a bit laggy to play as well. The reset is laggy as well. So yeah, yeah, I can show you that it works, I guess. Okay, so B, and then it sends a signal to the display showing, making it red, I mean. So yeah, here's the stripped down version, and here you can see about how big it is. Now let's take a look at the cells. So here in the same world I have the cell right here. So yeah, again you can see that it's pretty small. I'm really happy the way it turned out. Has pretty much all the features you would want as well, apart from the speed factor, I guess, but I'm not sure if you would call that a feature. Well, I guess. Anyways, so the most important part of this cell is probably the carry circuit that I used. So let's say you press to reveal it. If it turns out it's a 0, what will happen is that it will trigger a grid like this, and as you can see it will light up all the surrounding cells, simply using signal strength instead of separate signals, I guess. So as you can see it's just a mess of wires going straight up, straight down, left, right and diagonal, just in order to make it reach exactly the cells I want. So then what would happen is if it lights up and it's not revealed, it will reveal itself and then basically do the same, triggering the carry circuit and trigger its own neighbors, but only if it's a 0, of course, otherwise it shall not trigger its own neighbors. So yeah, really simple but powerful way of carrying the signal to its neighbors. So that's the magenta part right here in the back. It's also used for the reset, but I will tell that a bit afterwards. A bit later is what I meant. So right here we have a basically the memory for the display. This will also indicate when it's a bomb, so then when you press the button right here, all that has to happen is that these blocks right here need to shift to the left in order to make the signal pass through a solid block like this wall and basically display on the screen like so. So yeah, that's basically the most important part, showing you the value. Then the signal goes all the way here, checks if it's a 0. If it is, this torch will be turned off and the signal will go, I mean a monostable right here will trigger, and that triggers this carry circuit. So then the carry circuit will power this gray circuit in its own neighbors, and that again powers the orange circuit. So that will again reveal its neighbor, or reveal the cell which would be the neighbor of this cell, and also trigger the monostable again if it's a 0, and then again reveal its own neighbors, and so on. So yeah, that's the basics of the game, or actually that's pretty much the whole game. It's really not that complicated. Then of course we have the flag cell feature. All that does is block the input for the reveal cell, so it will drop down this send, so no signal could pass through. and it will also power this blue circuit right here, which will simply power the correct lines to show a F on the screen. And also one important thing it does is it will extend this block right here, which cuts off this orange circuit, which means that if you would or if this cell would get revealed by its neighbor because of the carrying, it will not trigger the screen to reveal its own value, because without that it would still do that, but it was already flagged, so it will basically just mess up the whole screen. So yeah, that's basically how you play it. So I will now tell a bit about the reset. So when you start resetting it, this signal will turn off, and that will basically trigger the reset within the cell, which would mean that this tape cycles back to its original position, which is this position where the green is, yeah, like so basically. And it will also like reset this latch, like this is latching into itself, and will reset that by dropping the sand downwards. And yeah, that's basically the reset. All that has to happen in the cell itself, but obviously the cycling of this back to the start is pretty slow. That's what causes the most lag. And then what it starts doing is picking for as many times as you have selected mines on the display. Basically it will start sending signals that many times to a random x coordinate and a random y coordinate, and at that coordinate there will be a cell, of course, and that's at that cell both this line and this line will turn off, so it's an AND gate between the x and the y basically. And as you can see, it would send a signal through this torch directly into the carry circuit. So as I told before, this carry circuit is used when revealing its neighbor cells. But yeah, it's also used for the reset, because what would happen is if the signal here is strong enough, it will set up the cell to be a bomb, so it will cycle to the bomb value within this state basically, and it will set a bomb latch right here, this latch with pistons. But it also will send a signal to its neighbors, and its neighbors will simply see that signal and use it to count 1 upwards on the piston tape. So the piston tape will just cycle 1 position, which means that it would then be a 1 when it was a 0. But if it was a 1 already, it will be a 2. So it's a really simple way of basically showing the correct number of mines that surround a cell on the screen. So yeah, let's say we would do this. This cell will get a mine, and all of these 8 surrounding the cell will add 1 to their value. So then there's also one little detail. If it selects a cell which was already a bomb, it obviously needs to add another bomb, because yeah, you can't have 2 bombs at one location, so otherwise you would have 1 bomb to view. So what would happen is this cyan circuit right here will basically detect that it was already a bomb, then retract this piston and send a signal back all the way to the start through this cyan line, and that will simply add 1 to the amount of bombs that still need to be added to the game. So yeah, that's all that's in the cells. So now I have 2 other components I can tell you a little bit. So this is the loose win neutral indicator, I guess. So yeah, it's a 3-state piston tape basically, which is sort of, yeah, it's flush with the wall. So it's not too interesting obviously, but we did use an interesting piston tape layout, as you can see right here. And that is simply because of the speed, because we need to retract the block 2 blocks back. So you can use a double piston extender, but that will take like 6 ticks or something to complete at least. So what we did instead is basically make activate these two pistons at the same time and then these two at the same time, and that will make it only 4 ticks, or maybe even less, I don't know. So it's way faster anyway, so I will just show it in a bit in action. And what I also did is use, as you can see, I have 3 different colors here that you can select individually, but they are on the same line. So I basically use signal strength to detect when it's at the correct position. So right here in these quadrants, signal strength is saved, and when it matches the signal strength of the ledge right here, it will basically stop cycling. So if we would select orange, as you can see, it has now selected orange, and I hope you could see the piston tape working a bit as well. I was quite laggy, so I'm not sure if it was really visible, but yeah, you get the idea anyways. So you can select the same color that was already selected and it will just do a full loop. Here you can see the tape nicely. And yeah, that's basically all of it. It's just a piston tape, but yeah, I kinda like how it looks, and it's nice how it works with signal strength. And then last but not least, we have the mine selector display. So I used Peter Yang's display, which is basically this 8 by 8 by like 4 wide design, so it's really small, but obviously it's quite hard to get an output of it from it. So what I did is basically got my own output of the button and inputted it in my own design right here below it. So all this is to store the value in like signal strength form below this counter, and then I can use it to get the correct amount of pulses out of it. So as you can see, it says 12 on the screen right now. When then also in this magenta part of my circuit, it has 12 stored as well. When I would start the resetting, basically this would trigger, and that stores the amount that's stored in the magenta part also in the orange part, so it basically resets the orange. And then what would happen every time you would start basically the counting by sending one signal into this machine, and every time you send a signal into the machine, it will subtract 1 from the first row. Then when the first row runs out of values, basically, so if it the signal strength reaches 0, it will look at the decimal above it and see if that's still bigger than 0. If it is, it will subtract 1 from that and reset its own number to 10, and then this one would do the same with this, but obviously you will never have that many mines, I guess. And as long as the first one is not 0, it will output a new signal, which basically with a bit more delay than this would run right back into itself. So as you can see right there, it will do 12 pulses, which is quite a lot, so you can count them if you want, but there's really no need. And if we just wait long enough, it will stop automatically after those 12 pulses. So yeah, it should be there, and it's done. So then, yeah, basically you can do this again, you can reset it again, and then it will have 12 stored again, and you can get 12 pulses out of it again. So yeah, it's kind of big, but it's a really nice system still, I think, to get a nice output out of this display, and I think it works pretty well together. So yeah, that's basically all the interesting, or all the mechanics I used in this build. I didn't go into depth too much because I know this video will already be really long, because I'm really bad at explaining stuff correctly. So anyways, I hope you still enjoyed this video, and yeah, I will see you all later. Bye.